Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're getting back to the Soroc IQ 120. This is part 3 in this little mini series here, so if you haven't seen part 1 and then part 2, I recommend you watch those first. There will be links down below. In the first part, I took apart the terminal and we determined that there was some serious blast damage on the power supply that would have prevented this thing from working. In the second part, I had to figure out whether I was going to try to fix the power supply or replace it entirely using switch mode power supplies. Well, I decided to go down the track of trying to fix it first, and it turned out that it was possible. This cap here was the culprit that was causing all the issues. This cap seems to have leaked all over the place and caused a short, which seems to have damaged the PCB, but I was able to clean it up and replace this cap, and we actually did some rudimentary testing, and I saw signs of life from the main motherboard. So that brings us to where we are now. The next step in trying to revive this machine is trying to fix this monitor. It's got really bad cataracts, and I don't think this CRT can be saved. The glue is leaked all over it. So I think the best thing to do here is try to replace it and see if I can get the CRT running. And if so, maybe in this video, we'll actually have a working terminal. So without further ado, let's get right to it. Before we get started with the CRT repair in this video, I was chatting with my friend Sark, who happens to own a couple of these IQ 120s. And Sark had some interesting stuff to tell me about the history of Soroc that I didn't really know about, because that Wikipedia article we looked at in part 1 was pretty light on details. So here's what Sark had to say about Soroc.
The story, as I understand it, was basically that some LSI engineers were like, screw this company, we're going to go make our own terminal company, but with blackjack and hookers and beer. But they only did the last bit, with the logo and name Soroc, derived from the beer they were drinking at the time, Coors beer. The name is an anagram, and the logo is the top of an old pull-tab beer can. The construction of the Soroc IQ 120 and the LSI ADM1 are so similar, it's uncanny. Before designing the IQ 120 terminal, Soroc also designed the Beehive B100 terminal, which also is very similar. There is also this coffee mug, which implies Soroc had something to do with point-of-sale terminals at McDonald's in Canada.
So that's some interesting stuff. It's really curious about the coffee cup and that association with McDonald's. Yeah, kind of interesting. Anyhow, let's get back to the repair of the CRT so we can hopefully get this thing up and running in this video. So for trying to fix this old CRT, as I mentioned in part 1, it's possible to try to remove this safety glass that's on here. This is the cataracts, which is the glue that's in between the safety glass and the CRT degrading. It's a very messy procedure, and I mentioned heat is one of the ways you can try to get this apart. And a few people, rightly so, mentioned that you could try using a heat gun on this to also loosen the glue. You could stick something in there, like a wooden chopstick, for instance, and then apply a whole bunch of heat and just gently pry and try to get this safety glass off. Once it's off, you can try to kind of chip away at all the glue and clean it up, and you should have a nice shiny piece of glass, both the safety glass and the CRT itself. The safety glass on these CRTs typically takes the place of an implosion band, which is a thick steel metal band that surrounds the glass here just to help prevent implosions if something strikes the front of the glass. While you do see a band on here, and it's made out of copper, I don't think this is actually an implosion band because it's pretty thin, and I think it's more an electrical connection between the tabs here that hold the CRT onto the chassis and the DAG, which is the ground of the CRT. The CRT, if you imagine, is a large capacitor where the high voltage goes in here, and on the outside you have this dull gray paint, which is called aqua DAG, and this is essentially the ground or the negative side of this capacitor. And it goes underneath the band up here, and then it's mounted onto the chassis, and then the chassis is grounded down to the CRT board. There were some green wires that connected to this little screw right here, and that's all part of the electrical circuit that makes up the CRT. So I don't think this takes the place of the implosion band, meaning taking off the safety glass and just leaving it off, it's probably not a good idea. So typically what's done is once you get everything super cleaned up, you put a bead of silicone around the edge, you let it cure. Of course, you have to have this thing sitting facing straight up, and then you place the safety glass back on so that there is a gap between it and the glass on the CRT, but at least you have an extra layer of protection. This might be something that I might attempt in a second channel video. I'd like to do it outside for safety. And of course, it's winter, it's raining, it's cold out. It probably won't be something I do until the summer. So I'll just stash this thing away until then. And for now, what I think the best approach is to just simply replace the CRT. I have this one, which I don't even remember where I got. I think this is an amber. It, of course, has the implosion band on it, so there's not a safety issue. And you can see here at the top where the implosion band is kind of crimped together. I also do have the deflection yoke and the connector that was from the original monitor. I can't remember exactly where I got this CRT from, but I think it was from a monitor that was physically damaged, like beyond repair. So I just cut the wires here and took this thing out of there just to save CRT. Now, what I had mentioned previously in part one is that when you take the safety glass off, you have an issue where you no longer have this thickness there. And that means that you might have a gap when you put the machine back together. Luckily, with this particular setup, it turns out that the mounting screws that are on here screw into the bottom of the chassis, and the whole module can slide backwards and forwards with about 1 centimeter or ½ an inch or so of play. And when I took it off, it was mostly towards the back. So that's good. With the other CRT in here, I can slide this forward, and then that should hopefully take up any of the space that was taken up by this glue and safety glass. The other thing, of course, that's possible is I could just simply put some washers underneath the fasteners that are holding the CRT on, and that will bring it forward as well. Now, with this particular CRT, I happen to know by looking in the service manual, this is a P4 phosphor or white CRT, same as a Macintosh. It's that bluish white color. And I'm quite sure that this CRT that I have here is amber. So this thing is going to become a Soroc IQ 120 with an amber screen, which is probably a configuration that from the factory was never actually offered. Now, when we look at this chassis here, of course, the power supply board, which sits in the bottom, is also the CRT driver board, and I think that's working. It should be. This is the flyback transformer right here, and it connects up to that driver board through this, and then we have the deflection yoke connections here. Now, I am concerned, speaking of the deflection yoke, that this thing has had a whole lot of oozing from the glue that they put in this over the years, and it has leaked down through the deflection yoke and all the way onto the neck here, because I see evidence of that here, like a bit of corrosion and stickiness there. And it was on the connector that also plugged into the CRT here. What I'm worried about is that this has caused these windings to corrode. Now, this is enamel-coated copper, so it's not like it's exposed to the air. But if there were any little nicks in the enamel, maybe this stickiness has gotten in there and has created some open turns here, which could be a problem for us because a lot of times the yoke is impedance matched to the driver board, and therefore, even though there's a spare one on this CRT, it may not be compatible. But I think I'm getting ahead of myself by worrying about that now. The first thing to do is just try to get this deflection yoke off, and I can inspect it, and we can also use the LCR meter to measure the inductance of it. Okay, so that came off, and it's corroding, that's for sure. For removing these, I typically recommend you just grab it and turn it, but this thing is all sticky, so I'm gonna put a paper towel over it so I don't put my glove on there. And you just sort of grip it and turn it, and it is turning freely, and then it should just slide off like that. And this is gross. There's all the sticky residue in here. Yuck. For the high voltage anode cap, things are very sticky and gross here as well. So I'm just gonna get this in here, this plastic tool, and try to unhook this. Gotta look in there to see what it's doing. There we go. Ugh, sticky. Now, as I was mentioning a moment ago, CRT is a big capacitor, and you don't want to just disconnect this if this thing has recently been used. I think this CRT probably runs at something like 12,000 volts or so, and like any capacitor, it can retain that charge for a little while. Some flyback transformers have a little bit of a bleed resistor thing going on in there that will bleed down the high voltage when you shut the power off, but not all of them. So you can't really trust that, and you do need to discharge that first. So you need to do that safely, and I didn't need to do it in this case because, of course, this thing hasn't been used in a million years. Now with this deflection yoke, it's really gross in there. So I'm gonna spray a bunch of 99% IPA on it, just sort of let it soak. And I'll probably take the toothbrush to it as well. I bet even now when I lift this up, we'll see brown. Yep, it's starting to get brown under there. I have no idea if this stuff is corrosive long-term, the stuff that came out of the CRT, but I would rather it just not be on here at all. And it seems to come off with the IPA, and this is 99% IPA. Now, as I do this cleaning, I am paying attention here, and I'm just looking to see if I see any signs of, say, broken wires or corrosion. And when you look inside of here, you would see corrosion as green spots. And I see absolutely nothing that looks concerning in here. Everything seems fine. I mean, we're seeing a ton of junk come off of it though. Ugh. All right, I'm just gonna let this sit here for a moment and kind of stew. And we can turn our attention back to this CRT. So getting this out should be pretty easy. I'm gonna bring out the impact driver again. Okay, I didn't really need to because the screw, at least that bottom screw, was already loose. So was that one. Yeah, that was loose as well. So was that. Okay, they're all loose. And I'm just gonna hold the CRT on the bottom while I take out these top fasteners. All right, there it is, it's free. And it's looking pretty gnarly. Look at that mess. It's not like it's not cleanable. Of course it is cleanable, but that's pretty gross. And here on the chassis, the leakage sort of ended up over here as well. I feel like I dodged a bullet a little bit here with this because there's a little bit of the leakage down here in the bottom of this chassis, and it could have easily leaked onto the PCB itself, and that could have caused all sorts of damage, obviously. So we have little copper tangs here. These touch the DAG as well, and it looks like this one is completely covered in the gunk. Okay, so that's a lot better now. That looks clean. I think it should actually make contact with the back of the CRT when you install it. Right, so with this replacement CRT, one of the things that's different about it is the high voltage anode connection is on the top here, while on the old CRT it was on the side. I'm not sure exactly what is the difference between one CRT that has that and another. I've found that it doesn't seem to matter. Nice, there we go. Definitely can see that it has a bit of a yellow tint to it. I wonder if the front glass actually has a bit of a tint to maybe make it a deeper orange. So this is the connector for the CRT itself, which is good to have a spare just in case the one that is from that board is damaged because it had all that gunk in it. This is a little piece of the high voltage anode cable. And then the deflection yoke, the wires are cut. Now I wouldn't have done that if there was a connector, but a lot of times on monochrome CRTs, it seems like these are actually soldered right onto the board, hence the cutting. Now what we can do is we can actually measure the inductance of this coil versus this dirty one here, and we can try to figure out, well, if they're compatible with each other. So first step, of course, to measuring this one is getting the wires stripped. Now when we look at the colors on this one, these are more normal, red and blue and yellow and black. There's no particular rhyme or reason to which goes where, like which is horizontal and which is vertical. So I'm gonna have to figure that out on this one. Normally you would just use the deflection yoke from the monitor that you are swapping the CRT into. I'm just still a little concerned about this one because of all the gunk that's on it. Okay, so first let's measure the inductance on the coil that came from the other monitor. It's gonna be in millihenries. 73.58 for that one. One will be in the double digits like that, and the other one should be single digits, if I recall. Now we're measuring the black and the yellow wire, and 119.1 microhenries. So we got 119 and 73.58 microhenries. So I was wrong about one being in the single digits. Okay, so I'm on the white and brown wires on the yoke that's on here, and it's 118.9. Well, that's so close to this other one, that would work. And the other wires, orange and red, and that's 10, 9.996. Yeah, the fact that one of the windings on here, 73 millihenries, and the other one is 10 on this one, that means it's not compatible. So we need to hope that this deflection yoke has no issues and absolutely works. And because of that, I think I'm gonna do a little bit more cleaning on here. I see a whole lot of brown gunk in here still. Yeah, this is pretty gross. A lot is coming off of here still. You can see it, it's just gunked all over. Looking at this band here, this is what was holding this onto the other CRT. You can see where the goop was. Definitely left some corrosion behind. And I think at this point, it's diminishing returns. That's relatively clean now. This, on the other hand, you could go with this forever. There's some kind of a plastic in here and maybe a resin already that holds this together, kind of keeps the shape. And I don't want to potentially eat that away. What I need to let it do is dry. So this 99% IPA should dry relatively quickly. I'm just gonna take away this nasty, nasty paper towel. While the yoke dries, I should try to figure out how to get this into the monitor chassis, because of course this is our new problem, this giant cap here. Well, I think I've run into a little problem. The shape of the CRT is, I think, a little different. I think it sticks out a little further back, and therefore these components don't necessarily clear here. Now, the way this board goes in is the standoffs are installed. You push it in and then push it down onto the standoffs. But with the CRT there, that's not working. It's possible that once it's pushed down, that the CRT will clear. There's a capacitor right there and there's the heatsink right there. But as it sits right now, it's not clearing. And I know I got this board out with the CRT installed, but I don't think that's necessarily possible, not with this CRT. So what I'm gonna do is I'm just gonna loosen the fasteners on the top, and then I'm gonna take the bottom ones out, which will allow me to tilt the whole CRT. So like that kind of a thing. And now maybe I can get this into place. Okay, that is in the right spot, and so is this. Let's push it down. And push that down. Get this all pushed into place. Okay, I think it's all in place now. Will the CRT go back without hitting? Yes, it clears. It does clear. Awesome. Actually, I think there's a couple of the fins here are touching. So we just bend that over, and now there's plenty of clearance. Yeah, it was just touching right here in the front. But that tall capacitor there, no problem. It clears without any issue. And then I'm able to reattach the CRT connector there. As for this cap here, I suppose one thing I could do is just drill a couple holes here and put a zip tie around it. And now I think the deflection yoke has sufficiently dried. Oh, I need to disconnect the CRT connector first before you can slide this on. I'll slide that on like so. We'll need this clamp as well. I'll just tighten the clamp just loosely so the whole yoke can turn. It may be upside down, the whole image might be wrong. Looking at the deflection yoke here, these cables are the same connector. So I should have paid attention when I unplugged them. I'm gonna have to go review the footage to see how to reconnect those properly, because that connector is obvious how that goes on. Okay, footage has been reviewed, and I wrote some notes for myself. Looks like I need to twist the yoke over because the yellow-black wire goes on the left side over here, and the yellow wire faces towards the left side there. And with the red and blue, I wrote it goes on the right side, the connector is down there, with the red facing towards the front, as in the front of the CRT, like that. We can make an assumption that the yellow and black wire is almost certainly the horizontal deflection, and we can say that because this part of the circuit over here is where the flyback transformer is connected to, and the horizontal deflection is an integral part of the flyback and the high voltage generator. Meanwhile, the vertical deflection, which is 60 Hertz on this thing, is more like a speaker output. So it's lower power, and it makes sense that it's over on this side of the board over here. I also went ahead and zip tied this large capacitor into the chassis here. It's possible I could have done it on the outside actually, because I think there would have been enough room based on the space inside the computer, but it fits there perfectly well anyways. There was already a hole in the chassis here, so I didn't have to drill anything. I just put a zip tie through it, and then I installed these 2 additional zip ties to hold the capacitor in place, and yeah, this is good. That thing is not gonna move there. Right, and with that, I think we're actually ready for testing. So I'm gonna grab the chassis for the computer itself, get the motherboard and everything all hooked up, and let's see if this thing works. All right, this is the way I have everything connected up. So the motherboard is connected to the chassis here. And the one thing you have to consider is these 2 connectors are not keyed. On the motherboard, it just has pins, but without a shroud around it. So even though the connectors themselves have beveled edges that would prevent you from flipping them around, the motherboard without the shroud doesn't prevent you from doing that. So you need to make sure you pay attention to the silkscreen markings on both connectors and get the connectors lined up and installed perfectly. I need to have access to these 2 controls here, because remember, this is the brightness and the contrast control for the CRT if it actually works. And due to the distance from the keyboard here to the motherboard, I don't obviously have the keyboard connected to anything. So if this does work, or should be able to see something on screen, but I won't be able to type anything. And in that case, well, maybe I need to remove the keyboard from the chassis here, and I can plug it into the motherboard where it connects up right up here. I don't think I noticed this before, but these chips here, look at the footprints. They're twisted slightly. How unusual is that? I guess there was just not enough space and they had to make space by slightly turning the footprints and everything. That's pretty amusing. All right, and I'm going to be using my phone here with the Spectroid app, just so we can see the 15 kilohertz if this thing is generating high voltage. Remember that this CRT here does not have a free running oscillator, so if it wasn't getting a video signal from the motherboard, you would have no high voltage, or deflection, of course. But we know, based on the testing we did in the last part with the oscilloscope, that there was vertical and horizontal sync. Okay, I'm gonna reach behind here to turn this on. Remember to look for a spike or something like this on the phone. Where's the power switch? Here we go. That beeping was weird, but we're getting 15 kilohertz. I see nothing on the screen. No smoke though, that's a good thing. All right, so let's turn these controls back here. Well, neither of them seem to do anything, so I'm turning them both to their extremes. So both of them all the way to one side, and then all the way to the other side. On the phone, 15.598 kilohertz, which is perfect, but nothing on the screen. So for a CRT to display anything, you need a few things that have to happen. You need the high voltage, 10 to 12 kilovolts or so. You need to have a heater on the cathode. That's usually around 12 volts for a CRT like this. You need to have a cathode drive signal, and then you need the appropriate grid voltages that go in front of the cathode, basically help the beam make their way to the front of the glass here. So the first thing I'm going to do is I'm going to use this high voltage meter here. This is designed for checking high voltage on CRTs. I'm going to check to see that we have appropriate high voltage. All right, the set is off right now. I'm going to turn it on. At least that beep was more normal. And we'll turn this on. Yep, okay, good. We have high voltage. You can see it's around 12 kilovolts, which is exactly what it should be. If I turn off the terminal, here we go, the high voltage fades down to 0. This tool actually does bleed off the high voltage, so it's actually really good for that if you have to remove the cap. I think what I need to do next is I'm going to need to check voltages and signals that are going into the CRT itself. Now, unfortunately, this little thing has a cap on the back, so I can't easily probe it. But I think what I'll do is I'll just keep this disconnected, have to turn the system on, and then I'll have to check for voltages. I brought up the handy schematics, which luckily has the pin numbers for the connector that goes onto the CRT here. So see 6, 7, 1, 4, 5, 2, etc., etc. So I went ahead and looked at the connector, which has pin numbers on it as well. So we have 1 through 7, and these are the wire colors, and then I've matched them up to the schematic here to kind of show what they are. So we have focus, screen, heater, cathode, and the G1 brightness control. That's the green wire. That is based on the knob that's on the motherboard. I'm going to use the multimeter that's on the virtual bench here just because it's a little easier to see it all on screen. So just to show that I have a good connection, I'm going to go to the black pin, the ground pin on the CRT, and that is not working. And we have to remember that this was filled with that corrosive PVA glue gunk. So it's quite possible we just have a bad connection in here. And if there's no ground, well, none of this stuff's going to work. And if I touch my little test lead here down to the end of one of these green wires that comes from the chassis ground, yep, we definitely have ground. And these should make their way, I think, back to this black wire here, which when we look here at the schematics, pin 4 for the heater, it absolutely just goes directly to ground. Well, and that means, unfortunately, I guess I'm going to have to remove the CRT port again. So I clearly should have spent a bit more time checking those connections, going to the PCB there, because I already found a fault. I'm just going to pull this all apart, and I'll do a jump cut. Oh, I just have to breathe. OBS crashed, and it sucks. OBS, when it crashes, often the file it's creating gets corrupted. Luckily, in this case, it didn't seem to corrupt the file, which is good because I would have lost a bunch of footage. Anyway, I took the PCB out of this thing. The only way to access the bottom side, of course, is to remove it, which is kind of frustrating. That's because there's a solid metal plate here. And the schematics were wrong. It says here that pin 3 is what goes through a 22 ohm resistor to 15 volts. Well, pin 3 on the connector itself is the brown wire. But the reality is the black wire, which is hooked up to pin 4, is actually the one going to the 15 volt rail. And it's pin 3, or the brown wire, that is hooked up to ground. That's not a big deal. The color of the wires doesn't really matter, and the heater can be hooked up either way. Just a little bit of an error in here that caused me to take a measurement mistake, which is what made me take this whole thing apart. And if I put the probe for the multimeter here into pin 4, which should be 15 volts, and we turn on the computer, and we bring up the power here by turning this on, There we go, 15 volts. Okay, good. So we already measured that. We knew that voltage regulator was working. That means if the CRT were plugged in, the heater would be getting the correct voltage. And with the 22 ohm resistor, it should drop the voltage to around 12 volts. All right, so I am plugged into pin 1 here, which is at 77 volts. And I think this is a brightness control. So I'm going to turn these potentiometers on the motherboard, and you can see this has a proper effect. So the closer it is to ground, I think the brighter the picture should be. So that appears to be working fine. So this is the motherboard brightness control is good. According to the schematics here, does it actually show the voltage range? Okay, yeah, you can see here that it's hooked up to a -130 rail. There are a couple different jumpers here, CJ9, and it lets you control how much the range of the brightness is between this 37 volts and the -130. And once again, what are we getting range-wise? We're getting from positive or negative 37 volts all the way to 118. I wonder if this is written incorrectly and this is minus 37 volts. Either way, the values though, they seem reasonable, and that's what I'm really looking for. Okay, let's check pin 6 and 7. So this is the screen voltage, pin 6 or G2. And that can definitely result in an all black picture depending on the CRT if you do a swap. Now PR2, there's a potentiometer on the board that allows us to adjust this. I did not try adjusting it. It's probably something I'm going to need to do to make this CRT work compared to the one that was in here. I moved the probe here into pin 6. The power's off right now. Remember, this is going to have potentially up to 400 volts. So let's turn this on. 200 volts. That may be way too low. Let's get a potentiometer here. What color wire are we talking about here? I think it's the red wire here. Okay, so this also adjusts the range here. Not very good. I think this other pin here is focus voltage, 164 volts, and I think this potentiometer adjusts that one. Okay, oh, this thing can only go up to 400 volts. Interesting. I'm going to put this down around ground. Typically focus on a lot of CRTs is around ground, so I'll just turn that all the way down. And here's sheet 2. So this is the 440 volts for G2 or grid 2. Oh, you know what? This also feeds the focus voltage, and we did see the focus voltage go up high, which implies that this obviously is getting the 400 volts. It must be this voltage divider here between PR2 and R16. 8.2 megohm and 2.5 megohm that set up this G2 voltage here, and I think it's too low. I think that's part of the problem here. What's a bit odd to me, and I don't quite get it, is where does this go? What's this arrow pointing to? I don't know. All right, I've gone ahead and reconnected the CRT because I know that the brightness control is the rightmost potentiometer on the motherboard. And then I know which one is the screen voltage. So I'm going to turn those around and fiddle with those and see if anything happens on the front of the CRT. Unfortunately, because of the way I'm recording with OBS, you won't be able to see that. No, adjusting everything, I don't see a raster. That's what I'm really looking for. I need to be able to see a raster because even if the cathode drive circuit or the motherboard wasn't outputting a video signal, we should be able to get a raster on the screen that will tell us that the deflection and everything else is working properly. And I'm just not getting that. But we validated here is that we have high voltage. That means that the deflection coil, at least the horizontal part of it, is working fine. Therefore, we should at least be seeing a horizontal line, even if the vertical deflection part of the circuit was broken. And we're not even seeing that. I can't get any raster to show up. And yeah, I think it's all about this G2 voltage being too low around that 220 or so volts. So the schematics have this handy little chart here. And it shows different CRT types. Clinton, Sylvania, the one I put in here is a Clinton brand. Yep, it is, I can see the sticker. The one that was in here when I took out, the one with the cataracts, so there's no sticker, well there's a sticker, but it's unreadable, but it's just a warning sticker. It seems the original sticker with the brand or whatever has fallen off, but I'm assuming it's an Amperex or Philips. And that's because when we look at these different voltages that I measured, like the grid 2 voltage, it says typical 280 volts DC. And when I adjusted the pot, it was around 220 to 270 volts, which totally coincides with this. Also the focus voltage, well, typically 0 to 400 volts. I have a feeling, I don't know, part of this is missing, but I wouldn't be surprised if it's also 0 to 400 volts. And 12 kilovolts on the anode, which is what we're getting on both of them. And the grid 1 voltage, which is the brightness control, that is a little bit different as well. 0 to minus 125 volts on the Philips. and it's plus 35 to plus 57 volts on the Clinton. I think though we can get away with the fact that it's not exactly right if the grid 2 voltage was more correct with this plus 400 volts. I'm kind of thinking right now of stealing the connection pin 7 here for the focus, hooking the original wire just up to ground, which generally is going to be good enough. And then what I'll do is I will take the plus 400 volt signal that's coming out of this, because if we adjust this potentiometer all the way to one side, we're just going to get plus 400 volts, and feeding that directly into the screen or grid 2 here on the CRT. And maybe I'll be able to get a raster then. So of course that means I need to do some cutting on here. It's the red and the blue wires here. These are the two that I'm going to need to cut. I'm fully assuming as I strip these wires that we're going to find a whole bunch of that stuff in there. Oh no, I thought we'd be getting that sticky goo in there, but it looks like we're not. All right, so first thing I'm going to do is the blue wire that goes to the CRT. This is focus, so we're going to connect that to a clip lead here, which is going to ground. Might as well reconnect this to the CRT. And then I'm going to put a clip lead between the blue wire, which was the focus voltage, and I'm going to hook that up to the red wire here, which is the G2. And we're going to leave this green wire just not, or this red wire, I mean, not connected to anything. That was the old G2. And I want to measure what this new G2 voltage is. So I'm going to connect this clip onto here. So we're going to be able to see it on the multimeter here. So when I power this up, I'll be able to adjust the pot right here. It should be this pot. And we should get this to like 400 volts, hopefully. Okay, here we go. Make sure no smoke comes out of this. Here we go. Okay, here we go. We're at, what, 43 volts? 84 volts? I'm looking at the front of the CRT, 200 volts. 300 volts. Oh, I think I might be maxed out. Oh no, not quite. 360. 400, okay, so that's as high as it can go because that's the boost voltage coming from the flyback, and that's going into G2, and I'm seeing nothing on the screen. I'm gonna adjust these potentiometers on the motherboard here, and nope, that is doing absolutely nothing. I mean, you know, there's one thing to consider here. I'm gonna turn the power off, is maybe, that should drop away very quickly. Yeah, less than a volt. Maybe the CRT is bad. I never even tested this. I probably should get the CRT tester, and we should probably put it on this CRT and see if the emissions are working and things like that, because it could be we got a short in here or it's just a bad CRT, and that's why I'm seeing absolutely nothing on the front. All right, I have the CRT analyzer out, the TR850, which is the same thing as the, I forgot the name of the US brand. This one came from Germany though, because these are hard to find. I've modified it for 120 volts. I have this plugged into the original Cataract CRT. It's sitting there on the ground, 12 volts heater voltage. So, and right now I have it on the shorts mode, so it would be lighting up here if we have any shorts on there, and we could try to clear them if there were any. We can check the cutoff here, and that is working well already. Let's see, there are two different cutoff voltages here. Yeah, okay, it's going to be the lower one, 300 volts. So we just set it to the little first notch on there, and that looks good. And let's try variable G1. Oh yeah, this thing's got decent emissions. Okay, so right now it's maxed out. It'd be the same if we check the emissions test here. So it's 0 volts to the cathode. And I haven't let this thing warm up, or sorry, burn in or wake up, because usually when these haven't been used in a while, you got to let them sit for a while. If we hit life test, it lowers the voltage to the heater, and you're looking for that needle there in the top left to drop. It's barely dropping. Yeah, I'm going to say that this CRT is in pretty good shape, actually. There's the original one that's on here. So if I did the cataracts removal, I'd have a decent white CRT, actually. Not bad. So if we go back to G1 variable, this allows us to adjust the grid voltage all the way down to minus, I think, 100 volts. It's kind of like the brightness control, the one that's on the motherboard on this particular system. So yeah, emissions are great. I mean, they're not like, it's not pegging the meter here, but it's also not horrible. As it sits here a little bit, by the way, the cutoff is actually getting a bit better. That's normal. Like I said, this thing kind of sleeping for a while. Now it's waking up. All right, so let's switch to the other CRT. Take this connector off here. And the problem is here is this fan is in the way, and it's riveted, the bracket that's on here. I can't get this this connector on there. All right, so one of the things I have are some of these homemade adapters. And I think with this, I should be able to make it work, because I can disconnect, like this is for color CRT here, I can unplug these connectors here and I can connect up the matching one for the monochrome CRT. I had these from my old CRT tester where I didn't have any of these adapters here, the ones that came with it. So I had to make my own. So this is the one that's for this connector here. So all I need to do is connect up these cables here. And the cathode connection, that goes to green. It doesn't really matter, but I'll connect it up to green. And because this is flat, and I salvaged it off an old CRT of some kind, I should be able to make this connect up there. All right, same story. I have it on shorts, 12 volts, power this on. No shorts, that's a good thing. Let's check the cutoff here. Yeah, on the 300 volt setting, there's absolutely nothing. 600 volts? So we turn cutoff all the way up, the needle just barely moves, and that's at 600 volts here. Yeah, cutoff is absolutely terrible. But let's go back to the emissions test. I mean, we're getting some emissions here though. So the cutoff is bad, but we have emissions. And G1 variable, so this is from 0 to minus 100 volts for G1, which is like the brightness control. It's fine. So G1 is working without issue on the CRT that's in here. We should get a picture. There's no reason why we shouldn't have a picture. I have a feeling though, the issue is G2 needs to be more like 600 volts. All right, this thing is hooked up to G2 and I have it hooked up to what I think is ground. If I switch the tester into emissions test, 522 volts. And if I switch that switch from 600 volts to 300 volts, yes, look at that, drops right down. 233 G2 is much similar to what we're actually getting on this chassis right here. And we still do have emissions on here, but obviously it's less when we switch it to like that 200 whatever volts. And adjusting the cutoff does have an effect as well. So with the cutoff down around 25 volts, we have basically no emissions. And if I turn this all the way up here, we're gonna get up to like that 300 volts or whatever, 30 something volts. We have pretty low emissions. I still feel like we should see something with that. But if I switch this over to the 600 volt setting, now we're going between 525 volts and there, 200 something volts. Now normally what we do is we set this cutoff switch here, which seems to actually ramp that up a little bit, and we adjust this where the needle just starts to move. And you know what, like I said, it's barely moving with the cutoff turned all the way up. So we go back to emissions test, like that. There we go, 525 volts. That's what's measured on the G2 pin on the CRT. So unfortunately, I think what that means, I'm just gonna turn off the power here. I think what that means is that this monochrome CRT is just not compatible with this chassis. And that's specifically because this thing cannot provide enough G2 voltage that this CRT needs. And I don't know how to modify the circuit to make it work because obviously we're already putting 400 volts into this and I'm still not seeing anything. I feel like the appropriate G2 voltage for this CRT is probably up around 600 volts. And that's just not possible on here because the boost circuit on this board only goes up to 400, which is what we're giving G2 right now, and we're still seeing nothing. And since we know that that CRT with the cataracts on the floor there has good emissions, if I could clean that up and get that glass off the front, I bet you we'd have a good picture coming out of this thing. And I guess to validate that, what I need to do is take this CRT out of this chassis, put back in the other one. I'll clean up the back so at least it's not all covered in that glue. And let's see if we can get a raster on that CRT. Okay, so the Cataract CRT is back in. I reconnected the focus and the G2 and I put heat shrink and soldered those back together. And they are connected, the high voltage anode is connected. I have not tested this. Let's turn this on and see what happens. Okay, here we go. No smoke, no bad things have happened, at least not that I can tell. Looking for raster here. There is a filament glow, so that is good. All right, let's fiddle with these controls since I have fiddled with them. Oh, there it is. We have characters. Look at that. Okay, oh yeah, we got raster as well. All right, well, that kind of confirms. Oh, we got an extra beep out of this thing. We seem to have a lot of garbage on screen. All right, so this is contrast all the way down, and that is the brightness turned up. And we obviously, we have raster there. And we definitely have some geometry issues on here, actually. I see the bottom here. The lines are all scrunched together. The deflection should probably go down further. Now there are a couple extra potentiometers over on the other section of the board. I'm not gonna fiddle with those right now because there's really no point, since the CRT is usable, but not with the cataracts here, and there's no point to try to fix this geometry issue. It could be like a linearity issue, there could be a dirty pot there. There's a couple pots that do deal with the vertical over there, and yeah, I bet you they're dirty. And that's causing that. But what this does confirm is A, we have a working power supply, and B, well, the board is generating characters. We kind of knew we were getting a video signal because we could see that on the oscilloscope in part 2. And then we know that the CRT driver board is working for the most part. It's just not compatible with that other CRT. And what we know for sure is that this CRT board, while it works, it's just not compatible with that other CRT. I've never run into that before where I couldn't have just randomly swapped CRTs and had it work. Because usually in the G2 voltage and the focus voltage, there's enough range of adjustability to make it work. But in this one, there's not. G2 is just too restrictive with its range, and plus 400 volts for boost is just not enough for that other CRT. While this one, it's obviously fine. By the way, looking at the CRT there, it looks like it's all a bunch of the letter O, capital O, just the whole screen. I'm gonna power cycle the computer here, and I'm gonna do it quick enough so the CRT is still warmed up. Okay. Oh yeah, that just immediately goes to printing all O's. That definitely means that there's a fault on this board, because I'm assuming what this should do is once it initializes, it should clear the RAM buffer here. This might be just what we're looking at in the video memory. It should clear that. I guess that's not happening. It may also be that without the keyboard connected, maybe there's a reset that comes from the keyboard that's not happening right now. So we will not jump to conclusions that there's a fault in that board, but I'm definitely stuck here. I might have another 12-inch CRT that's compatible with this Amperex brand, but I don't think so. I don't have any other spare white P4 phosphor 12-inch CRTs. All the ones I have are either green or amber. And I think part of what we're dealing with here, is that still showing the same stuff? Yes, it is that this CRT was probably designed for television use, not for use in computer display monitors. But all the 12-inch CRTs that I have came out of computer display monitors, and I think those all generally run that higher G2 voltage than these TV style ones do. So I think that means I'm gonna need to shelve the repair of the CRT module that's on this terminal, at least for now. Once the weather's nicer outside, I will definitely try to do the cataracts repair on this thing using the heat gun and try to get the PVA glue off and reattach the safety glass. But until then, there's not much more I can do with this, because as I said, I just don't have a spare CRT. But that doesn't mean I am totally stopped when it comes to repairing the digital side of this terminal. In the next video, what I'm going to do is I'm going to try to hook this motherboard up to the RGB to HDMI, because it's a CGA-like signal anyways, so we can at least start to troubleshoot what's going on with all these O's here. So I guess that means that's going to be it for this video. So I thought that CRT swap would be an easy slam dunk, but that was clearly not the case. That's just how it goes sometimes. So get subscribed if you want to watch me in part 4, hook up the digital section of this thing to the RGB to HDMI so we can try to get this thing out of the 000 mode. And my fingers are crossed that all it's going to take is hooking up this keyboard to get that to happen, but who knows if that's the case. There's no CPU on this thing, so it's not a question of just reset line, you know, like normally I would say with a CPU. So it's going to be interesting. So anyways, I hope you enjoyed this video, this failure of a video. If you did, thumbs up would be appreciated, subscribe, all the usual YouTube stuff, and a huge thanks to my supporters. Their names are scrolling up the side of the screen. They make it possible I do this full time, and without them, I wouldn't be able to do this. So you can become a supporter down below. There's links, YouTube memberships, and Patreon. I really do appreciate that. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.